We're going to take a look at solving quadratic equations, and the technique we're going to be using today is factoring. In the last lesson, we looked at solving quadratic equations by graphing, and then the next couple of lessons we'll also explore other options. The solving by graphing is nice because it gives you a visual idea of what's going on and where your solutions occur. But we also discovered that sometimes you can't find the exact solutions. You can only estimate them. Now, solving by factoring often works, but not always works. But it does allow you to get exact answers when it does work. Now, the next couple lessons will also look at ways that will always work to solve no matter what kind of answers you have. Now, suppose we had this situation where two numbers multiply together to give you 12. Well, two numbers that multiply together to give you 12, it's possible that P could be 12 and Q could be 1. So that's one option. But that's not the only option. We could say P is 6 and Q is 2. Or we could say 3 and 4. Or we could say 4 and 3. Or we could say 2 and 6, and so on. We could even start getting into fractions, 1/2 and 24, 2/3 and 18, and so on. Really, there's infinitely many different possible options when you have two numbers multiplied together to give you another number, unless you're multiplying two numbers together to give you 0. Now, two numbers multiplied together to give you 0 means either the first number is 0 and the second number is something else, or vice versa. So we like it when we have two things multiplied together to give you 0, because it means either the first number is 0, or P is 0, or the second number is 0, Q is 0. I'd rather only have two options to choose from rather than infinitely many up here. So solving by factoring takes advantage of this technique of having it equal to 0. So when we're solving by factoring, we want to have it set equal to 0 so we can use this technique that either the first number is 0 or the second number is 0, versus having it set in to something else and having infinitely many options. So solving by factoring, we want to first of all get 0 on one side. We don't have that, so we'll go ahead and add 4x to both sides. I chose to take everything to the side where my x squared is positive. For me, I find it easier to factor when my squared term is positive. We could have taken the x squared to the other side and had a negative in front of our x squared. We'd still get the same answers in the end. It doesn't make a difference. So now we're going to go back and use our factoring techniques from the last unit. Remember, the first thing we always want to do is look at our greatest common factor. In this case, we can pull an x out. So now we have x times something in parentheses equal to 0. So we have two things multiplied together to give you 0. So either this first thing is equal to 0, or the second thing here is equal to 0. So I set them both equal to 0. Well, the first one's already got x by itself, so I'll put that down. Then if I solve this one here, I get -4. So these are the two answers that would make this original statement true. Now, the fundamental theorem of algebra states that if your exponent is 2, you're going to have 2 answers. If your exponent was 3, you would have 3 answers. Now, it's saying you have the number, your exponent tells you how many answers you're going to have. It tells you how many answers will show up. It is possible that some of your answers can be duplicates of the other. So here, we have this equation. We want to first of all get it set equal to 0. Once again, my preference is to take it to the side where the x squared is positive. So I'll subtract the 5x, subtract the 2. Once it's set equal to 0, we can go ahead and factor it. Now, we factored something like this in the last, whoops, sorry about that, in the last unit. So we're going to use our AC factoring technique. And I'm assuming that you're able to do that. So do use your AC factoring technique on this. And you'll end up getting this here. So you have two things multiplied together to give you 0. So you set the first thing equal to 0, set the second thing equal to 0, And then all we have to do is solve this. So we could add 1 to both sides of the first equation, divide by 3, we get negative 1/3. Here we just have to add 2 to both sides. So these are the two answers right here that would make our original statement true. So go ahead and try to do this one on your own. Set equal to 0 by adding 4. Use your AC factoring. Set each factor equal to 0. Now remember, you can only set each factor equal to 0 if your original problem was set equal to 0. And that goes back to that first slide that we were looking at, where when we were multiplying by, or two things multiplied together to give you something other than 0, we had infinitely many options. Two things multiplied together to give you 0, you only had 2. So make sure you have it set equal to 0 first. Same idea here. Try this one on your own and then watch the video. So we get this when we set it equal to 0. We'll use our AC factoring. We solve it. Now notice, I'd said earlier that the fundamental theorem of algebra says we're going to have two answers. We have x being 3 and x being 3. So x being 3 shows up twice, so we still have two answers. But if it's duplicated, we just write it once. One last problem. For the most part, this is like a Jeopardy problem. Remember, with the game show Jeopardy, they give you the answer, and you got to figure out what the question is. In these last problems, you were given the question, solve this equation, and you were asked to find the answer. So here, you're given the answers, and you're asked to work backwards to find the equation. Well, if we're going to work backwards, we just basically have to do the reverse process of all this. Well, what we did here, just a second, I think I'm going to copy this down. So we basically have to do the reverse process. So we got to work backwards. So we got to start from the bottom and work up. So the last step we had was x equaling our answers. So I'm going to put x equaling our answers. Well, notice it says we want to deal with integers. We don't want to deal with fractions. Well, if I don't want to deal with fractions, I'd have to multiply both sides here by 3. Well, that's kind of what we did here, right? We had fractions. We have to undo our fractions, so we'd multiply both sides by what we were dividing by. We don't have to do that here because we're dealing with a nice normal number. Now, we need to have stuff set equal to 0. So I'll have to bring over my 6 by subtracting 6, bring over my 2 by adding 2. The two things that were multiplied together to give you 0 are the two things that go in the parentheses. So the two things that were multiplied together to give you 0 are the two things that go in parentheses. Then we have to go ahead and get rid of the parentheses. So that means we just basically have to FOIL it out. So that's the reverse process. When you think about what we did here, just all our steps working backwards. So our answer is what we have down here in the bottom. That's our original question that we started out with, that we were looking for in this problem.